You see backward problems everywhere. Sarah spent half her allowance on a book, then $5 on lunch. She has $3 left. How much did she start with? Or this one. Mark filled the jar with water. He poured out half, then 2 more cups. The jar has 3 cups left. How much did Mark start with? Or this. Emma tripled her age, then she subtracted 4 years. The result was 20. What was Emma's age before? All 3 problems share the same shape, a chain of steps, a known final state, and the unknown is the start. Pause the video. Pick Sarah's allowance. Try it before I show you the trick. Hint: walk her steps in reverse. What happened last? Every forward action has an inverse. Adding 3 becomes subtracting 3. Subtracting 5 becomes adding 5. Multiplying by 2 becomes dividing by 2. Dividing by 4 becomes multiplying by 4. The inverse undoes the original. That is the first big idea. To walk backward, you replace every step with its inverse. Here is the trap. You do not just invert the operations. You also walk the chain backward, the last action you took. Undo it first. Look, start with 5, add 3, that gives 8, then multiply by 2. You end at 16. To return to the start, walk the reverse chain, last step first. 16 divided by 2 equals 8. Then subtract 3 from 8. That gives 5. Back to the start. If you flip the order, you get the wrong answer. Order matters. When should you reach for working backward? 2 simple checks. 1. Is the end state known? 2. Are all the operations reversible? If both are yes, walk the chain backward. Last action first. Apply the inverse. Then the next to last. Keep going. You arrive at the start. This works for money, for recipes, for ages, for any chain of reversible actions with a known finish. This is the reverse the operations rule. If a chain of actions ends at a known state, then apply each inverse in reverse order. Last step first. Look for the words. What did it start as? With a chain of steps and a known finish. That is when this rule applies. Learn, compete, and win. Visit competitivekids.org.